In this problem, we're going to use both forms of disjunctive syllogism. First, we're going to have a goal of the form P or Q. And you might remember that that statement is equivalent to not P implies Q. And if you're going to prove that, you would maybe do direct proof, right? And take your antecedent not P as a given and Q as the goal. And that's exactly what you do in the first form of disjunctive syllogism. After that, we are going to have a different statement of the form P or Q as a given. And we're also going to have not P as a given. And again, if you remember that P or Q is equivalent to not P implies Q, then that together with not P will give you Q by modus ponens. Okay, so that's the second form of disjunctive syllogism. Here's a statement. Suppose A, B, and C are sets. Prove that A intersect B union C is a subset of A intersect B union C. So a Venn diagram can help us to picture what this statement is saying. So let's try and draw 3 overlapping circles here as best we can. And I'll make this top one A, and then down here we'll have B and C. And the left side of this expression here says A intersect B union C. Right? B union C would just be everything in either of these circles. And then the part of that, which is also in A, would be just these 3 sort of pieces here, right? So that's the set on the left-hand side. And then that's supposed to be a subset of the right-hand side. Well, the right-hand side is A intersect B, which would be this sort of football shape here, just these 2 regions. But then we're taking the union with C, which would certainly include the other one over here, along with a bunch of other stuff, right? Everything else in C. Okay, so the first set I drew is certainly a subset of the entire set that I've colored in now. So we believe it's true. Let's work it out in terms of the definitions. We're given that A, B, and C are sets, and we're supposed to prove this subset statement. And we know the definition of that is that for all x, x in the left side implies x is in the right side. And we need to drop that quantifier by letting x be arbitrary. And then to prove that conditional statement, we can do direct proof. We'll move the antecedent over as given. And the consequent becomes our goal. And now we're going to need to use some definitions to break this down further. If we start with this one, x in the intersection of A and B union C means that x is in A and x is in B union C. And on the other side we have a union, which means that x is in A intersect B or x is in C. So there's where our disjunction comes from a union. And alright, well, for our conjunction we can just take that as 2 separate givens. And now here's our first disjunctive syllogism. We have to move either the negation of the first statement or the second statement over as a given. And we're going to choose the second one because it's a little bit simpler. So x not in C is a given, and then the other statement here becomes our goal. Okay. And we should write out the definition of another union to get another disjunction. X is in B or x is in C. And we can write out the definition of this intersection. X is in A and x is in B. And then here we have our second disjunctive syllogism. Right? If x is in B or x is in C, but we know x is not in C, then x must actually be in B. There we go. And we're done because we have that x is in A and x is in B. So let's write it up. We started out with this goal, and the definition gave us this universal statement. We let x be arbitrary to get this goal, and then we proved that conditional by taking the antecedent as a given, which left us with this goal. Okay. So let's put all that in the first line. Let x be an arbitrary, not just arbitrary, but an arbitrary element of A intersect B union C, A intersect B union C, and then we are going to show that X is in A intersect B union C. Good. Now from there, we that's where we wrote out definition of union as a disjunction, and then we did disjunctive syllogism. So we took half of this disjunction and took its negation as a given, and the other half became our new goal. So we should comment on that. Suppose X is not in C. We show that X is then in A intersect B. Okay. Now, what's been happening on the given side, right? We're going to want to combine this stuff, but we should say we're going to want to combine these, which become these, right, by disjunctive syllogism again to get X is in B. Okay, but where did X in B union C come from? Well, that was from up here, right? We wrote the definition of that, and then it gave us those two statements. Okay, so let's write about this disjunctive syllogism now. First I'll go ahead and just say what happened up here. So we know that X is in A and X is in B union C because of what we had there. Okay, possibly could have left that out, but I think it'll be helpful for the reader to have that written down as opposed to just this intersection statement up here. All right, and now for the disjunctive syllogism, because X is in B union C and X is not in C, we know that X is in B. And then to finish up, X is in A and X is in B, which was our goal. Okay. So we have just mentioned those two things, X in A and X in B. So I'll say because X is in A and X is in B, we have our goal, which was X in A intersect B. And we're finished.